You are not solid. Everything you've been taught about the physical world is a comfortable lie, and the truth is infinitely stranger. The building blocks of your body are actually ghosts of pure potential, and understanding them is the key to the ultimate question: why do you exist at all? The quantum ghost. What if I told you the chair you're sitting on isn't solid? That you aren't solid? Everything you've been taught about the physical world is a convenient fiction, a comfortable lie. The truth is infinitely stranger. The fundamental building block of your body is not a thing. It's a ghost haunting the corridors of reality. Understanding this ghost is the first step to answering the ultimate question: why does anything, exist at all? At the atom's heart lies the nucleus. But it is the electron that defines the atom's character and conceals the deepest secret. This electron is not a discrete particle on a predictable path. It is a smear of existence, a cloud of probability. Quantum mechanics dictates that until measured, the electron exists in a superposition of all possible states simultaneously. It is not in one place, it is in all places it could be, a wave of potential. It is both a wave and a particle, a paradox defying classical intuition. But this uncertainty isn't just a quirk, it's a fundamental law. This is the unnerving core of the Heisenberg uncertainty principle. The universe places a fundamental limit on what we can know. We can ask where an electron is, and the universe answers. Or we can ask how fast it moves, and the universe answers. But we can never ask both questions at once. The more precisely we pin down its location, the less we know its momentum. This isn't faulty instruments, it's a fundamental feature of reality. And the implication of this law should truly unsettle you. This implies something profound. The atom doesn't possess defined properties waiting to be discovered. Instead, it exists as probabilities, a ghost of potential, waiting for an interaction, an observation to force its hand. The act of measurement itself seems to collapse this wave of potential into a single point, forcing the electron to choose its location. This is the observer effect. It suggests reality isn't a static machine, but a dynamic, participatory event. The universe waits to be seen. And if you think that sounds like a philosophical daydream, you are dangerously wrong. This is not a fringe theory. This is the foundation upon which your entire reality is built. The chair you sit on, the air you breathe, the hand you see all are composed of these quantum ghosts, these clouds of probability, masquerading as solid matter through statistics. We are sculptures of potential, held together by laws that are themselves probabilities. So this is the material of which you are made. This ghostly architecture is the first clue. But this presents a new paradox. If the universe started as a simple fog, where did these complex ghosts, the atoms making up you, even come from? These creatures of possibility didn't just appear, they had to be built. And building them required a crucible of unimaginable power. The Cosmic Forge. For 300,000 years after the Big Bang, the universe was intensely simple, a vast fog of hydrogen and helium. The atoms of your world, carbon, oxygen, iron, did not yet exist. They had to be forged, and the universe first had to build a furnace. It started with the primordial gas. This gas wasn't perfectly uniform. Tiny density fluctuations gave gravity a foothold. Over millions of years, gravity gathered vast clouds of hydrogen. They condensed, spinning into massive clumps. As pressure and temperature spiraled millions of degrees, a new fire was lit. Nuclear fusion began. The first stars ignited. But this new, stable star is a cosmic lie. A star is a balance. Fusion pushing out, gravity crushing in. It's a cosmic engine burning steadily for billions of years, but this stability is temporary. When hydrogen runs low in a massive star, a spectacular transformation begins. This is where the real creation begins. With its fuel exhausted, the core collapses, heating to extreme temperatures. This heat ignites the helium ash. The star fuses helium into carbon. When helium is depleted, the core collapses again, hotter still, forging carbon into neon, oxygen, silicon, and finally, iron. The star becomes a layered onion. But this process has a fatal flaw. With iron, the process halts. Iron is the ultimate ash. Fusing it consumes energy. The furnace extinguishes. In less than a second, gravity wins. The star's iron core collapses at a quarter speed of light. The outer layers fall inward, strike the dense core, and rebound in a titanic explosion, a supernova. It is impossible to overstate the importance of this moment. This is one of the most violent events known. In that brief moment, the star releases more energy than our sun will in its entire lifetime. The shockwave triggers a final fusion, creating elements heavier than iron, gold, platinum, uranium, and scattering them, with all the carbon, oxygen, and silicon, deep into space. This is the great cosmic delivery mechanism. These stellar remains seed new gas clouds, enriching the void with raw materials. The calcium in your bones, the nitrogen in your DNA, the iron in your blood. We are remnants of these ancient calamities. We are pure stardust, but this just deepens the mystery. The universe is filled with stardust. So why is this pile alive? Why did these atoms, on this one small planet, suddenly do something impossible? They learned to organize. The Library of Life. The universe is filled with stardust, but for eons it remained inert. Yet in at least one world, unthinking atoms began to build, organize, and replicate, following a hidden code that would eventually awaken the cosmos. And the secret to your transformation lies in the geometry of carbon. Carbon is the great connector. Its 4 valence electrons allow 4 strong bonds, making it the perfect molecular backbone. Carbon can build long, intricate chains and complex rings, structures of breathtaking variety. It is the ideal scaffold for biology, the atom versatile enough to create the chemical vocabulary required to construct you. But an atom is just a brick. It needs a builder. For hundreds of millions of years, the young Earth was a chaotic laboratory. Its oceans were a primordial soup. Energy from lightning, volcanoes, and UV radiation churned this brew. Simple molecules formed amino acids and nucleotides. But this is still just chemistry. The true chasm, separating living from non-living, is replication. At some unknown moment, a molecule formed with a remarkable property. It could organize lesser molecules to make a crude copy of itself. Do not underestimate this moment. This was the threshold. This was the moment matter crossed from physics to Darwinian evolution. Once replication began, complexity could be preserved. Natural selection started. Molecules better at copying dominated. They weren't trying to survive. They were simply chemical systems better at persisting. These replicators built protective shells, the first cells, and stored their blueprints in a more stable molecule. And this molecule is an incredible structure. This is the Library of Life, a spiraling double helix of DNA. Here, atoms no longer just matter. They are information, a code billions of letters long, sculpted by nearly 4 billion years of trial and error. This code specifies how to build an eye, metabolize sugar, and construct your brain. This is the ultimate self-organization. Blind atoms, following simple laws, somehow conspired to write their own complex instruction manual. This fragile arrangement, this emergent phenomenon you call life, is an island of complexity in a violent cosmic ocean. To survive for billions of years, it required a sanctuary, a stable harbor. But this creates a new paradox. Life required billions of years of stability. How did it get so lucky? How did atoms find a safe harbor for that long? It was provided by the most patient and powerful force in the universe. The silent architect. An atom alone is insignificant. But trillions together awaken the weakest force to become the master architect, gravity, the silent hand that gives matter, you, a home. Gravity is the outlier, unfathomably weaker than electromagnetism. A magnet can defy a planet's pull. But this weakness is its power. Other forces cancel out. Gravity is relentless. It only pulls. And it has all the time in the universe. And it uses that time to build. After the Big Bang, tiny density fluctuations gave gravity its first purchase. Over billions of years, it pulled primordial hydrogen into vast filaments, separated by immense voids. This is the cosmic web, gravity's grandest design, the universe's large-scale structure. And inside this web, the architect gets personal. Within these filaments, it gathers stardust into spinning nebulae, which flatten into disks. A star is born at the center. Farther out, gravity sculpts leftovers into new worlds. Dust becomes pebbles, then boulders, then planetesimals, then planets. This is how our solar system was assembled. Gravity created Earth, placing it in a stable orbit, a quiet harbor. It built the stage where life's chemistry could unfold, undisturbed, for eons. For centuries, we thought we understood this. We were wrong again. We saw gravity as an invisible tether. But Einstein revealed a profound truth. Gravity isn't a force within space-time, it is the shape of space-time. Mass tells reality how to curve, curvature tells matter how to move. Our planet isn't pulled by the sunday, it follows the straightest path through a cosmos warped by the sun's presence. Gravity, the builder, has spent 13.8 billion years gathering atoms, sculpting you. But this reveals a terrifying conflict. Gravity builds. But the most powerful law in the universe, ruling over gravity, is not creation. It's a counter-command, demanding not order, but chaos. The arrow of time subatomic laws are almost indifferent to time. An electron moving forward looks like one moving backward. Yet in your world, time is a river flowing one way, governed by a single command. This is the arrow of time, and its decree is that everything must fall apart. This is the second law of thermodynamics. Perhaps the most inescapable law in physics. It states that in any closed system, entropy disorder, randomness, chaos must always increase. Order is temporary, chaos is the default. Crystals dissolve, stars radiate heat away. Given time, all complex structures break down into equilibrium. This march toward dissolution is the cosmos's ultimate destiny, and yet, you are here. We stand on a planet of breathtaking biological complexity. We ourselves are perhaps the most profound defiance, trillions of unthinking atoms organized into a conscious being contemplating this paradox. If the universe's end is a featureless void, how can it produce such extravagant order? The answer is not a violation. It's an exploitation. Life doesn't violate the second law. A living thing isn't closed. We are islands of order in the river flowing to chaos. We maintain our low-entropy structures by consuming organized energy sunlight, food, and expelling disorganized waste heat. In building one small pocket of order, we massively accelerate the total disorder around us. Our sun is a gigantic engine of entropy. We capture a fraction of its energy to build a leaf, or a cell, or your thoughts. This reframes existence. We are not inevitable. We are fragile, fleeting exceptions. The universe doesn't exist to create us. Its fundamental law works to unmake us, pulling your ordered atoms back to simplicity. Our existence is a temporary rebellion against the inevitable triumph of chaos. But this entire story, order versus chaos, is a lie, or part of the truth. We assumed we charted all reality. We were wrong. We stared at visible matter, the stuff making up you, thinking it was the main cast. It's merely 5%. The true architecture is hidden, held by an invisible scaffolding we're only just perceiving. The invisible scaffolding. We've spent history mapping stars, believing we mapped the cosmos. We were mistaken. We only saw the decorations, the 5% that glitters, missing the vast, invisible architecture. The first clue was a profound error, or so we thought. Astronomer Vera Rubin studied spiral galaxy rotations. She expected outer stars to move slower, per Newton, but she found they moved just as fast as inner stars. The rotation curve was flat. This wasn't a rounding error. It was a crisis. The observation was a complete contradiction. The only explanation: galaxies were embedded in colossal, invisible halos of mass. This invisible mass provided the extra gravity to hold outer stars in orbit. Without it, galaxies would fly apart. This wasn't a local glitch, it was universal. Confirmed in other galaxies and clusters, this missing mass was everywhere. The universe contained at least 5 times more of this invisible substance than all ordinary matter you have ever seen. We call it dark matter. But the name barely scratches the surface. It is dark because it's invisible. It doesn't interact with light. It doesn't shine, absorb, or reflect. And it's not matter as we know it, not made of atoms. It's a new, unknown particle, interacting with our world only through gravity. But this ghost isn't minor, it's the protagonist. This scaffolding is why we are here. Simulations show ordinary matter's gravity was too weak to form structures after the Big Bang. Your atoms would have drifted apart. Dark matter, being more abundant, collapsed first. It formed invisible gravity wells the scaffolding of the cosmic web into which normal matter later fell. Dark matter allowed galaxies to form. It's the foundation of your cosmic home. For decades, we've hunted this particle in deep underground detectors, shielded from cosmic noise, waiting for the rare tremor of its passage. So far, only silence. The discovery of dark matter taught humility, revealing your atoms are a minor component. But this immense pull is only half the dark equation. An even stranger, more powerful force lurks in empty space. A force not pulling, but actively, violently, pushing things apart. The cosmic repulsion. We assumed gravity slowed the universe's expansion. In 1998, astronomers discovered a terrifying truth. Something is pushing back, and it's winning. The evidence was hiding in plain sight. Using Type 1a supernovae as standard candles, they aimed to measure cosmic deceleration, but the universe wasn't behaving. The most distant supernovae were dimmer, thus farther, than decelerating models allowed. The only shocking conclusion: the expansion isn't slowing, it is accelerating, it is speeding up. This one observation broke cosmology. This discovery turned cosmology on its head. Acceleration requires a mysterious, repulsive force, an anti-gravity. We call it dark energy, masking our ignorance. It's not matter. It seems an intrinsic property of space itself. The energy of the void. As space expands, more space, and thus more dark energy, is created. The expansion fuels itself, and its dominance is absolute. This entity is nearly 70% of the cosmos, the true master. For billions of years, a battle waged. Gravity pulled, dark energy pushed. Gravity won locally in the youth, but dark energy now dominates. And the implications for you, for us, are terrifying. The future is bleak. If acceleration continues, ultimate cold isolation awaits. Galaxies beyond our local group will recede faster than light, disappearing over the cosmic horizon until our night sky is empty. Given incomprehensible time, this force might overcome gravity holding galaxies, solar systems, even atoms together. The Big Rip. We exist in a precious temporary epoch, balanced between gravity's pull and the void's repulsion. But this leads to the most disturbing question. This balance isn't the only one. Our entire reality, the fact you exist, seems balanced on an impossible edge of coincidence. So perfect. It looks like a setup. The fine-tuned conspiracy. An atom's existence is not an accident. It's a conspiracy of cosmic laws, so exquisitely balanced that the slightest change would mean a sterile void. Our reality balances on a knife edge. This is not an exaggeration. Consider the strong nuclear force binding protons and neutrons. If slightly weaker, only hydrogen could form. No carbon, oxygen, life. If slightly stronger, all hydrogen would have fused instantly. No fuel for long-lived stars that your complexity requires, or gravity. Unfathomably weak, yet if slightly stronger, stars would burn out too fast for life. If weaker, matter never coalesces. Nor stars, nor galaxies. And it's not just two constants, it's dozens. A staggering coincidence. Forces ratios, electron mass, dark energy's value all set precisely for atomic structure. For you, why? The anthropic principle suggests we ask backward. We observe these constants because we are here. In a universe where values didn't permit complexity, no observers would exist. We are products of a universe capable of producing us, a tautology or a deep clue. And it leads to a mind-bending idea. This leads to the multiverse. If our universe is one bubble in a vast cosmic foam, perhaps all variations of physical laws exist somewhere. Unfathomable universes, most sterile. But in an infinite lottery, inevitably a few, by chance, have the right laws for atoms, stars, life. We live in a rare, lucky universe. Our existence isn't a miracle, it's a statistical certainty, given enough chances. Our cosmos is one possibility made real, a set of information supporting our existence. But this raises a new, terrifying question. If you are just information, can that information be truly erased? Can you be deleted? There's a place where this is tested, the one-way membrane of a black hole. The information paradox. There is a place where existence is on trial, the event horizon of a black hole. Here we confront the ultimate question: can an atom, its information, be utterly erased from reality? According to Einstein, yes. General relativity states a black hole crushes matter, crossing its horizon into a singularity, a point where physics ceases. In this view, the atom's information, its quantum state, history is lost forever, annihilated. But this is where the real fight begins. This conflicts violently with quantum mechanics, which insists information can never be destroyed. It can be scrambled, hidden, but must be conserved. So, what happens when a particle falls in? Relativity says lost, quantum mechanics says impossible. This is the black hole information paradox, a deep contradiction. For decades, the greatest paradox in physics, the puzzle remained. Then, Stephen Hawking made a startling discovery. Black holes aren't completely black. They emit faint Hawking radiation. This carries energy away, meaning over incomprehensible timescales, black holes slowly evaporate and vanish. A brilliant discovery that made the problem infinitely worse. If the black hole disappears, what happens to the information? Hawking radiation appeared thermal, random, carrying no trace of what fell in. Information seemed truly erased, violating quantum mechanics. Physics was broken. A new idea was needed. This crisis forced a radical solution: the holographic principle. Information is not lost. It never truly falls inside. As an object nears the horizon, its information is smeared out and encoded onto the 2D surface itself. From our view, the object passes, but its information imprints on the boundary, like a hologram. As the black hole evaporates, Hawking radiation subtly carries this encoded information back out. Information is saved. The paradox forces us to reconsider matters. Perhaps atoms aren't things, but physical expressions of pure information. This forces us to reconsider everything. If you are not a thing, but pure information, what happens when that information learns to think? This takes us to our final mystery: information's journey from stardust to self-awareness. The conscious atom. For 13.8 billion years, the universe expanded in silence. Atoms forged in stars clumped into lifeless planets. Then, in one world, atoms organized and woke up. The cosmos began to wonder about itself. This is the story of you. We followed the atom's pilgrimage, from quantum fog to stellar heart, through primordial soup, into the replicating code of life. Now, the journey reaches its astonishing destination. That stardust, obeying impersonal laws, arranged itself into the 3-pound universe inside your skull, the human brain, the most complex object known. 86 billion neurons forming trillions of connections create a network dwarfing a galaxy's complexity. But this is where physics stops, and the true miracle begins. This structure does more than process information. It generates an inner world. It is an experience, feels awe, comprehends its origins. This is existence's profound circularity. We aren't intruders. We aren't separate observers. We are the universe, evolved to self-awareness. The atoms within us are atoms from nebulae. The laws governing your thoughts wheel the planets. Through us, the cosmos developed a mind to perceive its own grandeur. And this brings us to the final, perhaps greatest, mystery. The deep chasm known as the hard problem of consciousness. We can trace physics and chemistry precisely, follow electrical signals neuron to neuron, map the brain. But we cannot explain how or why that electrochemical activity blossoms into the subjective feeling of being. How does unthinking carbon, hydrogen, oxygen acquire inner life? How does matter wake up? What ignites the fire of awareness, of being you? This is the hard problem of you. We lack the solution. It remains the ultimate frontier, challenging our materialist understanding, but it offers a final, breathtaking perspective. We began asking why atoms exist. We saw how they're forged, organized, balanced on a razor's edge. Perhaps the answer isn't physical. Perhaps the universe isn't just particles, but a process, a story unfolding toward awareness. Perhaps atoms exist. So after 13.8 billion years, they could assemble into a being capable of asking the question. We are the universe's conscious atoms, the stardust that awakened. In our quest to understand the cosmos, we are the cosmos seeking to understand itself. But this leads to one final, profound, terrifying thought. If we are the universe's way of waking up, what happens when it fully wakes up? Or what if, in this vastness, we're not the first part to do so? The silence of the universe, the great why, suddenly feels less like a philosophical question and more like a warning. If you are part of the stardust that has awakened, subscribe and like this video. The greatest mysteries are still ahead, and our exploration is just beginning.